Hello, welcome to the A-Level Physics multi-choice question. If you want to try to answer this question yourself, pause the video now. If you got the answer D, well done. If you want to hear my explanation, keep watching. So two resistors X and Y are connected in series with a power supply of EMF 30 volts and negligible internal resistance. The resistances are made from wire of the same material. That means they're going to have the same resistivity, and the wires have the same length. X uses wire of diameter D, and Y uses wire of diameter 2D, so it's twice as wide. What is the reading on the voltmeter? Well, what we need to do is we can find the ratio of the resistances of X and Y, then we can find the ratio of the potential differences across X and Y. So the first thing we need to do is we need to know how these different diameters are going to affect the resistance of the two resistors. So I'm going to use the equation you're given on your data sheet. Resistivity is equal to resistance multiplied by cross-sectional area over length. And that tells me that the resistance is equal to the resistivity multiplied by the length over the area. Now, we're not worried about resistivity, we're not worried about length, so what we can say is the resistance is proportional to 1 over the area. Now the area is equal to pi d squared over 4. So I can then say that the resistance is proportional to the diameter squared. So if I double the diameter, like I'm doing in this case, I end up with 4 times the resistance. So I can say really nicely, I can say that the resistance of X is equal to 4 times the resistance of Y. So X and Y, the resistances of X and Y are in the ratio of 1 to 4. Now, that potential difference is shared across those resistors, or across any two resistors, in proportion to their resistance. So I can then say the potential difference across X over the potential difference across Y is in the proportion of 1 to 4. So that tells me that the potential difference across X is going to be 4 times the potential difference across Y. The other thing we know is that all the PD supplied must be equal to the sum of the PDs across the two resistors. So the PD of X plus the PD of Y must equal 30. So you can solve that. There's various ways of solving it. I'm going to solve it in the following way. I'm going to divide 30 by 5, and that's going to tell me, it's going to give me 6 volts. So the PD of X needs to be 4 times the PD of Y. So X is going to be 24 volts, and the PD across Y is going to be equal to 6 volts. You can do a quick check that 24 plus 6 adds up to 30, and that 24 is 4 times 6. So either way, the voltmeter is reading the PD across X, 24 volts. If you found this useful, subscribe to my channel, press the like button and share with people who might be interested. Thank you.